let's continue with the problems on arithmetic sequences. We've already done exercises 1 and 2. We're going to move on to exercise 3 on my sheet here in my notes. We are given an arithmetic sequence a sub n. So we know we have an arithmetic sequence. Suppose we know that a sub 5 is 200 and a sub 8 is 245. Find a sub 12, find the 12th term. So we know the 5th term is 200, the 8th term is 245, find the 12th term. Now, there's a way to do this with formulas, but actually this one I don't want to use the formula so much. I just want to kind of try to reason it out, because I think you want to realize you have that choice. Sometimes you can just reason it out. Sometimes you want to plug into the official formula. Here, what I want to do is, what I need to do is figure out what the common difference is, though. So let's let D equal the common difference. That's really the key to figure out how these terms are related to each other. So I know that a sub 5, if I take a sub 5 and I add on the common difference once, I'll get a sub 6. If I add it on again, I'll get a sub 7. If I add it on a third time, I'll get a sub 8. So a sub 5, which is 200, plus 3 times that common difference, has to equal a sub 8, which is 245. So just by reasoning things out here, I've created a little equation that I can solve for D. And what I'm going to do is I'm just going to subtract 200 from both sides, and I get 3D is 45. So divide by 3, D is 15. So I know what that common difference is. Now, I didn't give myself a whole lot of room here, but I'm going to try to fit it in. I can now figure out a12 just using this common difference in the terms I have. Because if I take, say, a sub 8, one of these terms I have, and I add on a common difference once, that's a sub 9. Add it on again, that's a sub 10. Again, a sub 11, again, a sub 12. That's going to give me my 12th term of the sequence. A sub 8, we already know, that was 245. I'm just adding on 4 times D is going to be a sub 12. But we know what D is now. So 245 plus 4 times 15 is a sub 12. That's 245 plus 60. 4 times 15 is a sub 12. So what I get is, what is that? 305. 305 is a sub 12. That's what we wanted to find. We just wanted to find out what that 12th term was. So without even using the official formula for arithmetic sequences, I was just able to reason through this and figure out that that 12th term had to be a 305. Now, I did need to figure out what D was, though. Okay? All right, let's go ahead and do another problem here. And it's kind of similar, okay? We are given an arithmetic sequence, so a sub n, we know it's arithmetic. We know a sub 3 is 80, a sub 8 is 79. We want to find a sub 20. Now, one thing about that method I just used, if terms are really far apart, you're adding on a whole lot of D's in between. So I am going to take an alternate approach here. You could use the same approach, but I am going to try to work from the general formula. So this time, we'll use that general formula for an arithmetic sequence. A sub n is a1 plus n minus 1 d. And if we're going to use that, we need to find a sub 1 and d if we're going to apply this formula. Now I can first find d. And I think I have to find d in the same way that I found d before. And well, actually, no. Let's go ahead and do this. First, find d. What we can say is a sub 3 is a sub 1 plus 3 minus 1 d. So a sub 3 is equal to a sub 1 plus 2d. A sub 3 is 80. It's a sub 1 plus 2d. A sub 8, using the same general formula, is a sub 1 plus 8 minus 1 times d. So a sub 8 is equal to a sub 1 plus 7d. A sub 8, we know, is 79, is equal to a sub 1 plus 7d. So I plugged into that general formula twice here, and what I have is I actually have a system of equations. I have two equations and two variables, so solve the system for a sub 1 and d. So, sorry, I'm going to scratch this first find d. That's not, I'm actually going to go right to a system of equations and solve for a sub 1 and d. And you can use any technique you know for solving a system here. I'm going to isolate a sub 1, 80 minus 2d equals a sub 1 in that first equation, and then I can substitute into the second. So I can take this 80 minus 2d and put it in place of a sub 1 in the second equation. I get 79 is equal to 80 minus 2d plus 7d, or 79 is equal to 80 plus 5d. 79 minus 80, that's negative 1, is equal to 5d. So I think I have here that negative 1/5 is d, or negative 0.2. And so I have my value for d. I still got to find a sub 1. So I'm just going to plug into my 80 minus 2d equals a sub 1. Plug into one of my original equations. 80 minus 2 times negative 1/5 is a sub 1. That's 80 plus 2/5 is a sub 1. Maybe I'll write these guys as a decimal to avoid. That's okay to use decimals here. 80 plus 2/5 is 0.4 is a sub 1. So 80.4 is a sub 1. And my d, I'm going to write that as negative 0.2, its decimal form. And I'm also going to write my solution down here because I didn't give myself enough room on this piece of paper. So now we have our formula. I can go back to my a sub n formula for the arithmetic sequence and write it as a sub 1 is 80.4 plus n minus 1 times my d value is negative 0.2. So I set up, used the two values I had to get two equations and two variables. I was able to solve for a sub 1 and d. I went and plugged them back into the general form. And now I have this formula for my arithmetic sequence. A sub n equals 80.4 plus n minus 1 times negative 0.2. And what we want is, what was that one? A sub 20. And now it's just a matter of plugging in n equals 20. So 80.4 plus 20 minus 1 times negative 0.2. It's 80.4 plus 19 times negative 0.2. 19 times 0.2 is 3.8. So we have 80.4 minus 3.8. And so that's 80.4 minus 3.8 is 76.6. There's my 820 that we wanted to find at the very beginning. And sorry, I should give myself a little bit more space, but I'm going to still bring the whole exercise in here on the screen. Just ignore exercise 5. So this was a more systematic approach to this kind of problem. We could have used the same approach that we used in the preceding problem, and that works just fine if that makes more sense to you. But again, this is a more formulaic way, plugging into the official formula, getting a system of equations that we solve, going back to the official formula, and finding the value that we want. Okay, now one more exercise in this section, exercise 5. We're going to graph the arithmetic sequence a sub n equals 15 minus 2 times n minus 1. And so what we need here is we need some values to plot, and I'm going to figure out a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. And let's see, a sub 1 is 15 minus 2 times 1 minus 1 is 2 times 0. That's 15. Of course, 15 is that a sub 1 value, right, from the formula. A sub 2 is 15 minus 2 times 2 minus 1 is going to be 15 minus 2 is 13. A sub 3 is 15 minus 2 times 3 minus 1. That's 15 minus 4 is 11. A sub 4 is 15 minus 2 times 4 minus 1. That's 15 minus 2 times 3 is 15 minus 6 is 9. And a sub 5 is going to be 15 minus 2 times 5 minus 1. So that's 15 minus 2 times 4 is 15 minus 8 is 7. And so the points that I'm going to plot are 1, 15, 2, 13, 3, 11, 4, 9, and 5, 7. And let's go ahead and do that. Now I have a sheet of graph paper ready here. So I'm going to label this with a sub n equals 15, 15 minus 2 times n minus 1. Again there. And I have 1, 15. So 1, 15 is right here. 2, 13, 2, 12, 13. So each square is 1 on the vertical axis, but I stretched out my scale a little bit on the horizontal so the points wouldn't be too close together. 3, 11 is here, 4, 9, and I hope you can see what's happening here. 5, 7, 5, 6, 7. Just the one observation I want you to make is that for an arithmetic sequence, these points all line up along a straight line. So for an arithmetic sequence, the points all lie on a straight line. So for other kinds of sequences, that won't be the case. I think the one we plotted in an earlier video, they kind of curved around a little bit. But arithmetic is sort of like the sequence version of something that's very linear, very straight line-like. So there's our graph of the arithmetic sequence a sub n equals 15 minus 2 n minus 1. And that's the end of this video.